I'm Julia Bell, and today's topic is IP version 6. Differences between IP version 4 and IP version 6. The most recognizable difference between IP4 and IP6 is the address space itself. IP version 4 is 32 bits and is expressed as dotted decimal notation. For example, 192.168.1.1. You notice that it's 4 sets of numbers, therefore the IP version 4. Each set of numbers is divided by a single dot. The first octet in a class IP version 4 is a class C address. So 192 tells me it's a class C. IP version 6 is 128 bits in length, much larger address space, and written in hexadecimal. It is defined by RFC, or request for comment number 4291. Let's look at decimal, hexadecimal, and binary in comparison. On the far left, what we call decimal or base 10. This is the number system we all grew up with as children. You counted 0, 1, 2, 3, 4, 5, all the way till you get to 9, with 9 being the largest number you could hold in any one place. At that point, you had to add 1. You'd carry the 1 in the next position, and the original column would now be a 0, so 1, 0, or 10. And you continued on adding 1 until you reached the end of that. Hexadecimal. Hexadecimal is what's used by IP version 6. You have anything from a 0 all the way to F as in Frank. The numbers go 0 through 9, just as your normal decimal base 10 would do. However, when you get to the next digit, which we would have gone 1, 0 in the decimal base 10, in hexadecimal, the next digit is an A as in alpha. 11 would be B, 12 is C, 13 is D, 14 is E, and 15 is F as in Frank. There is no G in hexadecimal or further. You end with the letter F as in Frank. By contrast, let's take a look at binary or base 2. The highest digit you can have here is a 1. So a 0 or a 1 in any place are your only two choices, on or off. A 0 when we're looking at a nibble, which is 4 places, which is what hexadecimal is written in. 4 of those, all zeros, would be equivalent to 0 in hexadecimal or 0 in the decimal base 10. The number 1, the first position would represent the 8s, second position the 4s, 2s, and 1s, so we have a single 1. Number 2, the 1 is turned on in the second place. A 3 is equivalent to, this would be the 8th place, the 4, so it would be a 2 and a 1 bit turned on, it's a total of 3. All the way down to F as in Frank, which will be all bits turned on for a total of 15. 8, 4, 2, and 1 bits turned on would equal 15. Note, 4 bits is half a byte, or half an octet. It's also known as a nibble. You will sometimes see the alternative spelling, NYBBLE or NYBLE. RFC 5952 is a recommendation for IP version 6 address text representation. It recommends that IP version 6 addresses be represented in lower case. You'll notice in my example, I used uppercase. This was done strictly to make it easier to visualize and to differentiate between the different types of addresses. Let's take a look at the format of an IP version 6 address. Here we have X colon 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 X for a total of 8 sets divided by a colon. Remember, in IP version 4, they were divided by a single dot. If you look at any one of these sets, any one of those, it could go as high as all Fs or as low as 4 zeros. The X is just a representation at this place for up to 4 hex digits. In binary, it could be represented as, this is just exactly one of these. It could have 4 zeros, 4 zeros, 4 zeros, 4 zeros. Remember, it takes 4 places to represent a single hex digit when you're talking about binary. So it could also go as high as all ones. Every 4 hex digits are equivalent to 16 bits, or 4 bits for each hex value. Here's the preferred format of an IP version 6 address. For instance, at the first, here we have all zeros, 4 zeros, we have 4 zeros, 4 zeros, 4 zeros, all the way across. This would be an all zero address. Notice the one below it. By contrast, it has 1 digit different than the one above it, but it's a very different address from the first one. Notice the one below, Frank 02 is how it starts out. Notice each one of these have 1, 2, 3, 4, 5, 6, 7, 8 sets of numbers. Another thing you'll notice in common, anywhere from a 0 all the way through an F as in Frank is possible. This one, for instance, has all A's. It could also just as easily have all F's. These are examples of the preferred format of an IP version 6 address, and they're all valid addresses. Thank you for listening to part 1. Stay tuned for part 2.